All right, so we're going to be talking about parallel elements. And then the definition is that two elements are in parallel if they have two nodes, leads in common. So here's an example. These two batteries, the current goes from here and from here, and then the current adds up and goes into here. So a node is any point in a circuit where two or more circuits elements meet. Okay, so we'll have another example. So here is a much clearer example. The current goes out from the battery, then it moves here, and then this current is split. Some of it goes here, and then another part goes here. So these two resistors are in parallel. Okay, because the current is split between these two, I can say here that I total is equal to I1 plus I2. So I can say that I total is equal to I1 plus I2 because the big current that comes from the battery is split into two here. Okay, and then I can have more than two. So for example, here is the big current that's coming from the battery is split into one. Then this current again is split into here. Then it's split into here. So here I have I total, I1, I2, and I3. So let's talk about parallel circuits. Okay, so they can come in different forms, no matter how funky they look, not get fooled, as long as the current is split. As you can see, the current is being split, then they are in parallel. The current is being split, then they are in parallel. Here the current is being split in three, here is split in three, so it could be a diamond shape, rectangle, square, it doesn't matter the shape. Bottom line is that the current is being split onto three different branches. So the key item is the voltage is constant. The voltage drop across parallel elements is always the same. So Vs is equal to V1, V2 is equal to Vn. So V across this resistor, if I get a voltmeter here, is going to be the same as V across this resistor across this resistor. So the voltage doesn't change. What changes, as we said, is the current. So IS or I total, maybe slash total, is equal to I1, I2, I3. And it's like this big current is come and then it splits here, here, and here. Okay. Yep, here is a more detailed image. The current at this node, at this point, is split into three currents. It's like one big pipe of water that's being split into three different pipes. So if I had 1 liter here, this liter may be split up into 0.5 here, a quarter here, and a quarter here. But the total is 1 liter. Okay. Okay, so here we talk about Kirchhoff's current law, and then this is like is like the conservation of matter. The sum of current leaving at a point is equal to the sum of current entering at that point. So here I total is equal to I1 plus I2 plus I3, or I1 plus I2 plus I3 equal I total. I mean, we're not going to add more current because the original current that comes from here has to stay out here. Okay, and the same point as this junction, I in A plus I in B is equal to I out A plus I out B plus I out C. Okay. We spoke about this. The I total, which is I1 plus I2 plus I3, comes in here. So here goes I1 only. And then here is I2 plus I3. Then I2 goes in here only. And then here is I3. And then on the way back, I3 comes in. it adds up with I2, and then here we get the total I1, I2, and I3. So let's try and solve this problem. What is the total current in the circuit, I total? What is the voltage drop across each resistor? So we know this one. We know that the voltage drop in parallel, so we're in parallel, is the same. So the voltage drop across each resistor is 12 volts. And then what is the resistance of each resistor? Here, that's something we need to figure out. And what is the total resistance? That's something we need to figure out. So the first very important rule in parallel circuits is that the total resistance in that circuit will always be less than the value of the smallest resistor. And that's a very important rule to smell test your answer. So just for argument's sake, if you have two resistors that are 1 and 2 that are in parallel, if your answer that the total resistance of the combined resistance of these two is 3, your answer is definitely wrong. And if your total answer is 2, your answer is definitely wrong. But if your answer comes out to 0.7, okay, maybe right. Okay, so that's something, that's a rule to smell test your answer. So let's get to the math now. So the first rule is called the sum rule, or product over sum rule. So the total resistance is the product of R1 times R2 divided by R1 added to R2. That's the total resistance. So let's do an example. So if we have two resistors, R1 is 12 ohms and R2 is 6 ohms. So what is the equivalent resistance? Is going to be 12 times 6 divided by 12 plus 6. So we know that 12 plus 6 is 18, and then 12 times 6 is 72. And then this will give me 4 ohms. So as you see, the R total is 4 ohms, which is less than the smallest 6 ohms. Okay, so what if I have a circuit that has 3 resistors in parallel, or even more, have 4 resistors in parallel? Then we would break it up into parts. So the first part is I would take these 2 resistors and I would calculate R total, which is this one for resistor 2 and 3. And then I would combine these two, or maybe let's do it this way, to get R total. Okay, so this is the universal formula for resistors in parallel. The product over sum rule is derived from this one, where the R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. This is a formula that you can use in case you have, I don't know, 10 resistors, whatever number of resistors, that formula would always work. But the product over sum rule, which is R total is equal R1 times R2 divided by R1 plus R2, this only works for 2 resistors. Okay. Okay, so let's solve this problem. I know that the voltage across the 3 resistors is 6 volts, so the total is 6 volts. And then every resistor has 6 volts on it. And then I know that R1, so let's label them. This is R1, this is R2, and this is R3. I know that R1 is 2 ohms, R2 is 3 ohms, and then R3 is 6 ohms. So let's calculate the R total. So we're going to take these two first, and we're going to calculate R23, which is going to be 3 times 6 divided by 3 plus 6. So that's 18 divided by 9 is equal to 2 ohms. And then R total, which is going to take all of this together, is going to be equal to, and then an R is going to be R1 times R23 divided by R1 times, R1 multiplied by R23 divided by R1 plus R23. And this is going to be equal to 2 times 2 divided by 2 plus 2, which is equal 4 divided by 4 is equal to 1. So all of this is equal to 1 ohm. So I total is equal to V over R, V total over R total. So V total is 6 divided by 1, so I total is 6 amps. Now let's calculate I1. So it's going to be V total divided by R1, which is 6 divided by 2, which is going to give us 3 amps. And then I2 is equal to V total divided by R2. V total is 6 divided by R2, 3, which is going to give us 2 amps. And then, of course, doing the math, this is going to be 1 amp simply by addition. Or we can just redo it again. I3 is equal to V total divided by R3, which is equal to 6 divided by 6, which is going to give us 1 amp. Notice that the smallest resistor, oh, I didn't put them in the right order, I apologize. So these are flipped. So these are 3 amps here, 2 amps here, and 1 amp here. So the smallest resistor carries the largest current, and then the largest resistor carries the smallest current. Okay? Now we calculate the power dissipated. So we know that P is equal IV. So we did that math before. So these are all 6 voltages, 6 volts. We know that the current through R1 is 3 amps. Current through R2 is 2 amps. Current through R3 is 1 amp. And the total current is 6 amps. And we know that this resistance is 2 ohms, 3 ohms, 6 ohms, and the equivalent resistance is 1 ohm. Okay, so the power is IV, so the power here is 6 volts times 3. We got 18 watts. And then the second one is 6 times 2, 12 watts. And then the third one, 6 times 1, which is going to be 6 watts. These, if you add them up, 18 plus 12 plus 6, you get 36, which is the same thing if you multiply 6 times 6, you get also 36. 6 times 6, it's equal to 36. So this is a way to also double check your answer, that the sum of these should be equal to the product of these two. If they do not match up, then there's something wrong in your calculation. Yep, so this is what we've said. The total power provided by the battery is equal to the power dissipated. Okay, energy is neither created nor destroyed.